Good morning and welcome to the first lesson of Doppler effect. Let's recap the transverse wave quickly. This is a peak and this is a trough. This is a cycle from the beginning of a peak to the end of a trough, and that is the amplitude, which is the height of that peak, and from the middle of one peak to the middle of the next peak is the wavelength. This is just a recap. Then frequency. This wave here has got a high frequency. You see that the waves are coming quickly up to one another. This wave here has got a low frequency. The waves are coming slowly. Okay, now very important. Do you remember this equation? Frequency is equal to speed divided by wavelength. Now from this equation, I just want you to know that frequency is indirectly proportional to wavelength. That means that if you have a high frequency, you have a small wavelength. And if you have a low frequency, you have a big wavelength. So if the one is small, the other one is big. So let's look at this slide again. Here you have a high frequency wave. Can you see that the wavelength is small? While here where we have a low frequency wave, the wavelength is bigger. Okay, this is very important. Frequency indirectly proportional to wavelength. Okay, the Doppler effect. When there's an ambulance coming towards you, these circles are representing waves. So when the ambulance are driving towards you, it is sort of pushing the waves together so that the frequency is increased. Can you see that the wavelength is very small here? Therefore, it's a very high frequency. Okay, now when the ambulance is driving away from you, the wavelength gets bigger and the frequency is then lower. So when an ambulance is driving towards you, the waves are pushed together and therefore they are coming close to one another, which means they have a small wavelength, high frequency. When the ambulance is moving away from you, the frequency is decreasing and the wavelength is getting bigger. Now let's look at an example of a video where it's a car with a router driving towards you at first and then driving away. Please note at the sound that is differing. Okay, could you hear in the video that the sound of the hooter when it came driving towards you sounded different than the sound of the hooter when the car was driving away from you? Now that difference in sound can be correlated back to the frequency of the wave. So in science, we are not going to talk about the difference in sound anymore, but we are going to talk about the different frequencies. When the car or the ambulance is driving towards you, the frequency is high because the waves are pushed together, lowering the wavelength. When it's driving away from you, the wavelength is bigger and the frequency is then lower. So in this example, the listener is the boy and the source of the wave is the ambulance. This would make more sense later on. But for now, you just need to know that the source is the thing making the noise, the car with the hooter or the ambulance with the siren. And whoever is listening or observing that sound is the listener. So let's look at a few definition type of examples. The Doppler effect. It can have two situations. The source can move then the observer is stationary. That is exactly like the video we watched. The observer is stationary and the car, which is the source making the noise, was moving. The second situation is where the source is stationary and the observer is moving. Okay, very important for you to note the two situations. The definition of the Doppler effect. This is an easy mark in an exam. Change in the observed frequency of a wave when the source or the observer moves. Very important. Now let's look at situation 1. The source is moving, the observer is stationary. So here is the source, this is a police car, and here is a man standing still, stationary, and here is a lady standing still, stationary. Now the source is going to start moving. When the police car with siren starts moving, it pushes the waves together, making the wavelength smaller, and therefore you have a higher frequency. So this lady would hear a higher frequency, while this man here, where the waves got a bigger wavelength and therefore a lower frequency, would hear a different frequency. Then we have a second situation where the source, the police car with the siren, is stationary and the observer is moving. The observer, if it moves towards the source, there will be a higher frequency because it is going through all these waves quickly. And the observer moving away from the source would go through waves slowly and therefore have a lower frequency. Okay, this is very, very, very important. The equation for calculations about the Doppler effect. Let's see what all these symbols stand for. FL is for the frequency of the listener. VL is the speed of the listener. Fs is the frequency of the source. Vs is the speed of the source. And V is the speed of the wave. Now, this is very important. This plus minus sign here, you need to choose when is VL positive or negative and when is Vs positive or negative. Now, if you just study this table, you will never get it wrong. Remember, we are having one situation where the listener is stationary and one situation where the source is stationary. So, if the source moves towards the listener is stationary and the source is negative. So then this will be 0 and this will be negative Vs. If the source moves away from the listener, speed of the listener is 0 and the speed of the source is positive. So this will again be 0 and Vs would be positive. Now we look at the second situation where the listener moves towards the source. Now the speed of the source is 0 and VL is positive. The listener moves away from the source. Now Vs is again 0, the source is stationary, and VL is negative. So if you want to do an example, you just need to remember this table so that you know when Vs is negative and positive and when VL is positive or negative. So let's do an example. The siren of an ambulance emits sound with a frequency of 700 Hz. You are standing on the pavement. If the ambulance drives past you at a speed of 20 meters per second, what frequency will you hear when the ambulance is approaching you and when the ambulance is driving away from you? Take the speed of sound in air to be 340 meters per second. Okay, the first thing you do is you take what is given in the question and you write it down. First, they give you the frequency of the ambulance siren is 700 hertz. So Fs is 700 hertz. V is the speed of the wave. The speed of sound is 340 meters per second. You are standing on the pavement, so the speed of the listener is 0. The speed of the source is minus 20 meters per second because the ambulance is driving at 20 meters per second and it is approaching you. So if you look at the table, the source moves towards the listener, so Vs is negative. Vs is negative. So now you insert it into your equation. 700 for Fs, 340 for V, 340 for V again. The VL is 0 because you are standing still, and the V of the source is minus 20. So if you do the calculation, you'll get to 743.75 Hertz. That is the frequency that you will hear when you are standing still on the pavement. Now let's see if it makes sense. Always check your Doppler answers to see if it makes sense. The ambulance is driving towards you, so the frequency should be higher. The frequency of the source is 700. 743 Hertz is higher than 700. So your answer is correct. Okay, daar's nog 1B. Kan ek aangaan?
Wat doen 1B?
1B is ja.
Okay.
So dis al. Dis net daai stukkie.
Doen hom vinnig en dan kyk ons.
As ons al daai goed uitsny, gaan dit dan inpas of nie?
Wat sal ons doen?
Alles doen ons, ek meen met die video en al my foutjies en goed.
Ek dink as ons hierdie doen, gaan hy oor tyd wees. Maar
Okay.
wat jy kan doen as jy hom doen, is sê net onthou nou, dis presies dieselfde as
Ja. Ja.
Nommers, dis net
Ja. Ja, okay.
Yes.
Yes. Okay. For the second part of this question, the ambulance is driving away from you. So all the information given is still the same, but now your sign of Vs is changing. Vs should now be positive if you look at your table again, because the ambulance is now driving away from you. So if we put the values in the equation, you have a positive 20 here. So if you get to the answer, it's 661 Hertz. Now let's see if this makes sense. When the ambulance is driving away from you, the frequency should be lower. The ambulance's frequency is 700 Hertz, and 661 Hertz is less than 700 Hertz. Therefore, your answer makes sense. Thank you.